everyone, welcome back to my channel Explore Edu to Teach. Today we are going to learn something about the basic of networks before we dive into the more complex topic of network analysis. I'm going to teach all the concept of network analysis to you, which will help you in your competitive exam as well as in your GATE examination, in your university examinations also. So please do follow me, subscribe to my channel, and I'll try my best to teach you all the concepts of network which is going to really help you in your study. So today we are going to basically learn about network and circuit, voltage across and current through network elements equations, and KVL and KCL. So these are basically, I can say, the basic concepts of network analysis. If you understand this concept of network analysis properly, then going into the complex topics in the future is going to be easy. So please, it's my genuine request, go through the entire video. Please make a note of all the points that I'm telling, and then as and when I put in more video of network analysis, it will be easy for you to grasp of. Also, if you like this video, share it among your friends and among your classmates who can also get benefited from it. So let's quickly dive into the topic. So the first topic that today we are going to learn is going to be about what is a network and what is a circuit. You need to understand that what do you mean by a network, what do you mean by a circuit, and eventually what is the difference between both of them. So if I have to tell about a network, what do you mean by a network? A network is basically an assembly of different electrical elements. So what is a network? A network is basically a assembly of different electrical elements. There can be two configurations in it. One can be, it can be an open network or it can be a closed network. So the assembly of different electrical elements is called as a network, and in that there can be two ways. The network can either be open or can either be closed. So let's try to draw a particular network. So I will say I have a resistor, I have an inductor, and I have a voltage source V, R and L. So this can become a network because it is definitely a assembly or a collection of different network elements like resistor, voltage source and an inductor. So this is, if you can say, a open kind of assembly. Similarly, we can have a closed kind of assembly as well. So to sum up, a network is basically a assembly of different network elements, and it can be open or closed. So it can be just be an assembly. Like for example, I have a voltage, I have a resistor, I have a inductor. Similarly, what do you mean by a circuit? So a circuit is a closed path. A circuit is a closed path of different electrical elements. So a network is basically an assembly of different electrical elements. It can be open, it can be closed. But a circuit is a closed path. So there is no option of open and close over there. So if I say open or close, the open option is eliminated over here. A circuit is a closed path only. So for example, I draw a voltage source, I draw a resistor, I draw a inductor, but it has to be in a closed path. It cannot be open like this. It has to be in a closed path. Hence, if I have to conclude, a network is an assembly of elements. It can be open, it can be closed. But a circuit is definitely a closed path only, in which we have a voltage, we have a resistor, and we have an inductor. Is it clear? Hence, I can say that every circuit, every circuit is a network, right? So a circuit is definitely a network because circuit is a closed path and network can also be open or closed. So every circuit is definitely going to be a network. But every network may or may not be a circuit, because if a network is open, if a network becomes open, it will not be a circuit. However, if the same network is closed, it will be a circuit. So I'll just summarize to you. A network is an assembly of different electrical elements. It can be open, it can be closed. But a circuit is necessarily a closed path of different electrical elements. Hence, to conclude, every circuit is definitely going to be a network because a network can be closed or open and circuit is always closed. But every network may or may not be, very important term, may or may not be a circuit. That means if I have a network, it can be open also. And if it is open, it will never be a circuit. But if it is closed, it will definitely be a circuit. So I hope I am very clear with this. If you have any doubts, you can put it down in the comment section. The next topic is the basic. Let's try to understand the basic voltage and current equations of a resistor, inductor, and capacitor. Please make a note of it into your notes because this formulas of voltage and current for a resistor, inductor, and capacitor is repeatedly going to be used in the future topics. So please make a note of it. So if the network element is a resistor, the voltage formula is given as I into R, where your I is the current and R is the resistor. Whether it is positive or negative, I will explain in the future slides. But please try to understand this formula, the basic formula. Similarly, I is equal to V by R. Now, for an inductor, in case of your inductor, your V is equal to L into di by dt, where L is the inductor and I is the current in the differentiated form. Similarly, your I is equal to 1 by L integration minus infinity to t V t dt. So I hope I am very clear with this formulas which I am telling you. Now the next set of formulae that we have is going to be for a voltage. Okay. So in case of your voltage for a capacitor, it is 1 by C integral minus infinity to t I of t dt, and I is equal to C into dV by dt. So I hope I am very clear with this. The voltage and the current equations for different network elements, V is equal to IR and I is equal to V by R for a resistor. For a voltage, V is equal to L into di by dt and I is equal to 1 by L integration minus infinity to V of t dt. Capacitor is equal to, the voltage is 1 by C integration minus infinity I of t dt and I is equal to C into dV by dt. So this is a basic formula. Please make a note of it and don't worry, I have a handwritten notes of all this concept. I will be talking about how can you get those notes from me in the last slide of this particular lecture. So please make a note of it, and for the complete notes I will be talking about how can you get it from me. The next thing is the KVL, that is Kirchhoff voltage law. So that is a basic concept. And what is Kirchhoff voltage law and what are the rules of Kirchhoff voltage law? We'll try to understand. So to give the definition of Kirchhoff voltage law, it states that Kirchhoff voltage law states that in any closed circuit, please pay attention over here. It is applicable only for a closed circuit. So in any closed circuit, the algebraic sum of voltage drop is equal to 0. Please make a note of it. So when you have KVL, that is Kirchhoff voltage law, it states that in any closed circuit, please make it a point and note it. In any closed circuit, the algebraic sum of voltage drop is always be equal to 0. Okay. So when I have a closed circuit, whatever voltage drop across all the elements is going to be equal to 0. Now let's try to understand the rules of it in a simple manner. Okay. And then we'll try to solve an example on it. A simple example so that you get a basic understanding of it. Hence, I'm repeatedly saying, please listen to this lecture properly and share it among your friends who also have doubts in this concept, because these are basic concepts. I am writing over here basic concepts of networks. If this is understood well, you can understand the future concept. But if here you have an issue, trust me guys, it's going to be difficult for you to understand the future concepts. So let's try to understand the basic conventions of a KVL and KCL. So firstly, imagine I have a voltage source, okay? You know this is plus, this is minus. Imagine I am moving in a closed loop in this direction from positive to negative. Mind you, my voltage will be written as minus of V. There can be other convention, but this is the convention that I follow, and even if you follow, it will be easier for you. Similarly, imagine I'm very sorry. Imagine I have such kind of voltage source and I'm moving in this direction. So in this case, my voltage is going to be plus V because I'm moving out of a positive terminal. In upper case, I was moving out of a negative terminal, hence it was minus V. Here I'm moving out of the positive terminal, hence it is plus V. Similarly, third one, imagine I have a resistor, okay, and I have a current going through it. So what is going to be the voltage drop across this resistor? Imagine I'm moving in the same direction. Again, I repeat, I'm moving the same direction of the current. My voltage drop is minus of I into R. And similarly, if I have a resistor and I have a current going through this way, and I'm moving in the opposite direction of the current, then my voltage is equal to plus of I into R. This is the basic convention that I follow. You can also listen to me and try to follow this convention unless until you are very comfortable with some other convention. But if you follow this, trust me guys, all other lectures that we are going to cover is going to be on this convention only. So it's going to be easier for you to understand. So if you have a voltage source over here and you're moving from the positive towards the negative, the voltage drop is minus V. Similarly, if you're moving from negative to positive, it is plus V. If you're moving in the same direction of current, it is V is a minus of I into R. And if you're moving in the opposite direction of the current, if you see over here, the direction is opposite, right? The current is this way, I am moving this way. It is plus I into R. So this is the basic understanding about sign conventions. Now we'll try to apply this onto a very simple numerical wherein we have a closed circuit, right? As I told you, Kirchhoff voltage law is applicable for closed circuit. So this is a closed circuit where I have 3 volts, I have 2 ohms resistor and a 3 ohms resistor, and I have a current I going through it in this direction. If you see, the direction is this way, right? And they ask me to find out the current I. So I will apply. These are the ways of writing even in your theoretical answer. So try to understand. Apply KVL in the closed circuit. So if you see, I am going to move in this direction. Try to understand. I am going to move in this direction. Okay. So accordingly, we'll try to understand. So I am moving from minus to plus. So what we had learned, when we are going from minus to plus, it is plus V, right? When I'm moving from minus to plus, it is plus V. So it's going to be a plus 3, correct? Because I'm going from minus to plus. Now I'm moving in the same direction. I'm moving the same direction in which current is going, right? The current will be moving how? This way, right? So when I am moving in the same direction as that of your current flow, then what is the thing? If my direction is in the same direction of the current, it is minus of I into R. So it is minus of 2 into I. Similarly, I am moving in the same direction of the current, right? Current is also moving this way, I. So it is minus of 3 into I is equal to 0. So just do the simple mathematics. Plus 3 minus of 5 into I is equal to 0, causing I is equal to 3 by 5 amperes. Please make a note of this thing. Please make a note. I know it's a very simple kind of question, but this simple question will make you clear of the concept that we have learned theoretically. So what did we learn? When I am moving from the negative to the positive, I'll have plus V as I mentioned over here. So we have plus 3 volt. If I'm moving in the same direction as that of your current flow, then I have minus of 2 into I. Similarly, minus of 3 into I is equal to 0. Why equal to 0? Because I told that the algebraic sum of voltage drop is equal to 0. Therefore, I is equal to 3 by 5 amperes. Is it clear? Any doubts over here? Okay. Don't worry, we'll be solving complex questions in the next coming lectures also. But please make a note of all these basic concepts. Once you understanding this concept, then solving the further concept is going to be easier. I hope I'm very clear. Okay. So let's begin up with the next concept, that is KCL, Kirchhoff current law. So what does it state? It states that, always start definition this way only. It states that the sum of currents flowing towards a junction, or I can say a node as well, is equal to the sum of currents moving away from junction. So the basic concept, try to understand theoretically, we'll try to see a question on it over here. Okay, so don't worry. So what does it state? It states that the sum of current flowing towards a junction is going to be equal to the sum of current moving away from the junction. So if there's a sum of current, you know, I'm sorry, I'm very sorry. So if I have a sum of, so I have current, for example, I have this junction, right, G, and I have current 1, current 2 coming towards the junction, and there are some currents going out away from the junction, right? 3 and 4. So I can say 1 plus 2 is equal to 3 plus 4. As simple as that. This is a very layman language. When we solve a numerical, we'll try to understand better. But what does it say? The sum of current which are going towards the junction or the node, any which term you can use, is equal to the sum of current moving away from the junction. I hope I'm clear with this. Okay. So let's try to solve a numerical on it. Okay. So what does the numerical say? Okay, I have this diagram where it's a closed loop. I have Ix going out of the, for example, if I consider this as A, Ix is going out of A, 5 amperes is coming inward, 3 amperes is going outward, Iz is coming inward, Iy is coming inward. So it's saying find Ix if Iy is 2 amperes and Iz is 0 amperes. Okay, so applying KCL at node A. So what does it say? The sum of current entering towards the junction is equal to sum of current entering away from the junction. So Ix, if you see over here, Ix is moving away, right? So Ix plus 3 ampere also moving away, plus 3 is equal to 5 amperes coming inward, Iy is coming inward, Iz is coming inward. So what does it mean? KCL, the sum of current entering towards the junction. The sum of current entering towards the junction is equal to the sum leaving the junction. So Ix and 3 is leaving the junction, right? And 5 is Iy, Iz is entering the junction. Therefore, Ix is, we have to find out, plus 3, 5, Iy is given over here as 2 and Iz is given as 0. Therefore, Ix plus 3 is equal to 7. Ix is equal to 4 amperes. So make a note of it. So I hope I'm very clear. What do you mean by KCL? So whatever current is coming inward is equal to the current going outward, and you can solve this. So I hope I'm very clear with this. I'll just give you a quick revision again. So what is a network? A network is an assembly. I repeat, a network is an assembly of different electrical elements. It can be open, it can be closed. But a circuit is a closed part of electrical elements. Hence, every circuit is a network because network can be open or closed. But every network may or may not be a circuit because network can be open or closed, but my circuit is always closed. So I hope I'm very clear with this. Then I have the equations for the voltage and current for resistor, inductor, and capacitor. Then we have what is a KVL. We learned the sign conventions and the simple numerical on it. Similarly, we learned what is KCL and we learned the definition and the simple numerical on it to understand better. So, if you want the complete notes, the handwritten notes for this particular thing, I will be mentioning my Telegram. Okay, my Telegram and Instagram. Link in the description box. You can follow me on both the apps, and I will be regularly posting all the short notes, everything over there. Also, if you require the complete handwritten notes for this topic, please comment in the comment section. I will try to provide you all in the best possible way I can.